Sine of the angle, x is in place of my angle, is equal to opposite over the hypotenuse. My angle is the angle where I'm standing. That's known as the reference angle, because in reference to this angle is the side opposite the hypotenuse and the side that's adjacent. If I was standing up here at this angle, the opposite would be down here and this would be adjacent. The adjacent side is always the side that's touching your reference angle, and the side opposite is the side across from it. Now the hypotenuse is always in the same place no matter what. As you're already familiar with, it's the longest side and it is the side across from the right angle. So sine is equal to opposite over hypotenuse. So if I wanted to set this up, my angle measure is 26. So I'm going to do sine of the angle measure, 26, equals the opposite, which is the x, over the hypotenuse, which we know is 200 meters. Okay, so now to figure this out, on your calculator, we have the sine button, so we can use it. And we already know the angle measure, so we're not going to use the inverse sine. We're just going to use regular sine. But I'm going to get x by itself. So think of this as just being a number. Don't let the word sine confuse you. This is just a number. If you type in your calculator, sine 26 is 0.43837, 0.4383711,468. But anyway, my point is, it's just a number. So don't think of it as anything else. So we're just going to use algebra. If I had some number equal to x over 200, how would I get x by itself? It's being divided by 200. So I'm going to multiply both sides by 200 in order to get that x by itself. It's the same concept here, except for instead of having a number, we have sine 26, which is a number. So I'm going to multiply both sides by 200. So 200 times sine 26, the 200 and the 200 cancel each other out, and I'm left with 200 times sine 26. I just typed it in the calculator, 200 sine 26 equals, that gives me my value for x, 87.67. So x equals 87.67 meters. And on your test, I'll always probably ask you to round to the nearest tenth. So if I want to round this to the nearest tenth, it's going to be 87.7. Okay, cosine is just the adjacent over the hypotenuse. So once again, you've got to look at where your reference angle is. Since this is my reference angle, the angle I'm given, this side is adjacent, it's touching. The hypotenuse, of course, is always the same place, the side across from the right angle, and it's the longest side. And this side over here would be my opposite. But I don't need to use the opposite. I'm not looking for it. I don't have a measure for it. But I have this, I'm looking for the adjacent, and I'm given the hypotenuse. So looking for the adjacent, using the hypotenuse, I know I'm going to use cosine. So let's set it up. Cosine of the angle measure, which is 26, equals the adjacent, y, over the hypotenuse, which is 200. Same thing as the previous problem. This is just a number. So I have some number equals y divided by 200. To get y by itself, I've got to get rid of this 200 that's being divided from y. So I'm going to multiply both sides by 200. This cancels. So I'm left with y equals 200 times cosine of 26, just typing it in the calculator once again. I don't know if you can see that or not. I hope you can. Hit enter, and it is 179.75. 179.75. Once again, rounding to the nearest tenth. Since this is a 5, I'm going to round my 7 up. So it is 179.8. Now, we've got one more trig ratio, tangent. Tangent of the angle x is equal to the opposite over the adjacent. This time it does not involve the hypotenuse. So once again, my reference angle is down here. Across from it is the side opposite. Down here next to it, touching the angle, is the side that is adjacent. So I'm going to set it up the same way. Tangent of the angle, 26, equals the opposite, which is 200, over the adjacent, which is y. In the previous two problems, my variable was on top and I had a number on the bottom, but this time my variable is on the bottom. How am I going to get that y by itself? Well, first I've got to get it up out of the denominator. So since it's being divided by y, I'm going to multiply both sides by y. Okay, so it's gone from over here. Y over y is 1. 1 times 200 is just 200. Or we like to just say it cancels. So I have y times tangent 26 equals 200. This is nice because I don't have the variable in the denominator, but now it's being multiplied by this number. So just like in regular algebra, if I had y times some number equals 200, to get y by itself, I'm going to just divide by some number. So I'm going to divide by tangent 26. Tangent 26 over tangent 26 becomes 1. 1 times y is y, so it cancels. So I'm left with y equals 200 divided by tangent 26. That gives me 410.06, round up, so it'd be 410.1. Now sometimes you get triangles that have, want you to find multiple pieces of information. I'm only given one side, one angle, and I've got to find the other two sides. So you can start wherever you want, but I know that I'm going to go ahead and label it. I have to use this angle because it's the one that's given to me. So across from the 36 is the side that's opposite, and now the y is going to be the adjacent side, and the x is going to be my hypotenuse. So if I'm standing at this angle, and I want to solve for x or y, I've got to pick, I can't solve for both of them at once because I'm not going to have enough information. I've got to solve for, use the opposite and solve for the adjacent, use the opposite and solve for the hypotenuse. So let's start by solving for the hypotenuse first. I've got, standing at my reference angle, opposite over hypotenuse, so I know I'm going to use sine. Sine equals opposite over hypotenuse. So sine of 36 equals 15 over x. Once again, I've got to get that x up out of the denominator. Multiply both sides by x. X times sine 36 equals 15. Divide both sides by sine 36. And x equals 15 divided by sine 36, 25.51. So I'm going to leave it as 25.5. Okay, so that gives me x. Now I've got to solve for y. So it's going to be using the opposite. I could use the hypotenuse now that I know it, but I don't like to do that just in case I made a mistake. I like to always use the information that was given to me. So starting with sine, or not sine, but my reference angle, 36, using opposite, looking for the adjacent. I'm not going to use sine now. I'm going to use tangent. Tangent of the angle equals opposite over the adjacent. So tangent of 36 equals the opposite, which is 15, over the adjacent, which is y. Multiply both sides by y to get that up out of the denominator. Y tangent 36 equals 15. Divide both sides by tangent 36. 15 divided by tangent 36 is 20.64. So I'm going to round down again, 20.6. Now I can check myself using the Pythagorean theorem. I've got 15, 20.6, and 25.5. It already looks pretty good because these two sides are shorter than this side, so that's a good thing. So using Pythagorean theorem, I know that this side squared plus this side squared should equal that side squared. So 20.6 squared is 424.36, so we'll say 0.4. 15 squared is 225, which check my math just to be sure, equals 25 squared, which is 25.5 squared, which is 650.3. Add those together, 424.4 plus 225 is 649.4 equals 650.3. Now you're probably looking at that and saying, no, 649.4 is not equal to 650.3. But remember, we rounded these sides. So as long as it's somewhere really close, I mean, we're only off just a little tiny bit there. So we're off, what, 9/10? We're only off by 9/10. So that's not very much. So as long as it's approximately correct, then I know that I must not have made too many mistakes. I must not have made any mistakes because they're pretty close. Now I can find this missing angle down here. We know that all of the angles of a triangle add up to 180 degrees. So if I have 36 and 90, I subtract that from 180. And I get 54. Should have been able to do that in my head. Okay, so this angle is 54 degrees. And once again, I could have used sine, cosine, or tangent to find that, and I could use those to check myself if I wanted. But the easiest thing to do is just subtract them from 180. I know all the angles added together equal 180 degrees. Let's try one more together. And then we'll look at what to do if we're looking for the angle and given all of the side measures. Okay, so here's my reference angle. It's the only angle I'm given. I could find this one by subtracting them from 180, but like I said, I like to use the information that's given so you have less room for error. So I'm going to solve for x first. That is opposite. I've got to use the hypotenuse because it's the only other measure given. So sine of my angle, 42, equals the opposite, which is x, over the hypotenuse, which is 14. To get x by itself, I'm going to multiply both sides by 14. 14 times sine 42 is 9.36, so we'll say 9.4 is my x. Okay, so now I'm done with the opposite. I'm looking for the side that's adjacent, and I'm going to use the hypotenuse. Adjacent and hypotenuse, that tells me I need to use cosine. So cosine of my reference angle, which is 42 degrees, equals the adjacent, which is y, over the hypotenuse, which is 14. Once again, multiply both sides by 14. 14 times cosine 42 is 10.40. Okay, so I'm going to check 9.4 squared plus 10.4 squared is 196.5. 96.5. We know that 14 squared is 196. So once again, it's off just a little tiny bit because we rounded. So my answer is 9.4 for x and 10.4 for y. Okay, I think somewhere, yeah, here we go. Here's a problem where I'm given two side measures. I'm looking for a third side, and I am looking for the angle measures. Doesn't matter which one I start off with. Remember, I've told you this before, I think, but when we have the angles of the triangle, they're labeled with capital letters. So I've got angle H, angle Q, angle R. The sides are labeled with lowercase letters. Notice directly across from capital H is lowercase h. So if I was looking for this one, it would be labeled lowercase q because it's directly across from capital Q. And if I was looking for this side, it would be labeled R because it's across from capital R. But I'm just looking for H, and angle R. So let's start off by solving for angle H. I know that this side is the side adjacent, and I know that this side is the hypotenuse. It's directly across from the right angle. So using adjacent and hypotenuse, I don't have it written up there, but I'm going to use cosine. Remember the SOHCAHTOA. Cosine is adjacent over the hypotenuse. So cosine of my angle, which is h, I don't know it, equals adjacent over the hypotenuse. So I've got my fraction here. So what I'm going to do is I'm going to hit the second button and then cosine. And that gives me cosine, and it has a -1. That's the inverse of cosine, because I'm looking for the angle this time. So inverse cosine, 8 divided by 9, gives me 27.3. Okay, so my angle H, usually I will always have you round to the nearest whole number on the angles. So my angle is 27 degrees. Now I can easily find angle R several different ways. I can do 180 subtract 90 subtract 27. Or if you want to get fancy, you can stand here and say, okay, I've got the opposite now. My reference angle has changed. So I've got the opposite over the hypotenuse, so I can use sine. So sine of R equals 8 over 9. Same concept, I'm going to use second sine button, that's the inverse sine, 8 divided by 9, and that gives me 62.7. I want to round up to 63 degrees. We can check 27 and 63 make 90, 90 and 90 make 180, so I know that must be correct. Now I've got to solve for h. There is multiple ways I can solve for h. You can use Pythagorean theorem, 8 squared plus h squared equals 9 squared. You can use sine, cosine, or tangent, depending which angle you want to stand at. You can stand at this angle, you can stand at that angle, does not matter. Since I've already got this set up as my reference angle, I'll stand here, and I'll just go ahead and use the opposite over this side is the adjacent side. So that would be tangent. So tangent of 63 equals opposite over adjacent. I'm going to get that h up out of the denominator. I'm going to multiply both sides by h. So h times tangent 63, then I want to divide by tangent 63. So I have h equals 8 divided by tangent 63. And that gives me 4.7. If we round to the nearest tenth, that'd be 4.1. We can check it using Pythagorean theorem. 4.1 squared plus 8 squared is 80.8. We know that 9 times 9 squared is 81. 80.8 would round up to 81. So I must have done my math correctly. The nice thing about trigonometry using sine, cosine, and tangent is there are so many ways you can check yourself. You should never have a wrong answer because you can go back and check the sides using Pythagorean theorem. You can check the angles, make sure they all add up to 180 degrees. You can use sine to find an angle or a side measure. You can check it again using a different trig ratio. There's so many different ways that you can check your answers. So that's that.